So we will now discuss digital modulation techniques. Okay, and before we have studied the baseband transmission. In the baseband transmission, we have seen that we were transmitting the signal. It was no doubt that we were able to transmit the signal, but in transmitting the signal, we were had some limited scope there. Okay, the limited scope was in transmitting our signals through radio links, through satellites, and in these cases the baseband transmission find limitations. Okay, actually what's the problem with it? We are able to transmit the signal, but it transmits a signal with low frequencies. Okay, so it cannot be used to transmit a signal with high frequency. So it's the main problem and trouble with the baseband transmission. Now we are going to discuss here a new type of modulation, or a new type of modulation, okay, that's known as digital modulation or passband transmission. Okay, this type of modulation can be used to transmit a signal over radio links and satellites. What this type of modulation actually does, it shifts the frequency of the message signal to the higher frequency. In the next lectures, we'll see how we will be able to shift the frequency of a baseband signal to the higher, okay, to the higher ranks. First of all, here I have written the definition is here and its need is here. Okay, so now so far we have discussed digital modulation techniques. Okay, now we will discuss the types of digital modulation technique depending upon the receiver module. That means whether we are going to synchronize the carrier signal that were applied for the detection at the receiver end. Depending upon that, we are classifying the digital modulation techniques into two types. One called the coherent type, second called the non-coherent. In coherent, it's obvious we would be using coherent carrier. That means there would be need of synchronization of various receiver parameters, okay, of various modulation parameters. By modulation parameters, we mean different parameters that we are using in modulation. It can be phase, it can be time. Among the two, these are the most two that are discussed. Okay, these type of modulation and these type of synchronization are required. Okay, second is the non-coherent. That means here a non-coherent carrier would be applied. That means simply a carrier that would be applied, that would be generated by a local oscillator, and that would be directly applied to the product modulator without any synchronization. Okay, depending upon the scheme applied, there are two schemes of transmitting the signal, one called the binary scheme and second called the M-array scheme. In case of binary scheme, there are two possible message signals. Generally, we know in binary there are 1 or 0. At a time, we are able to transmit one of the possible signals. That is, at a time, we can transmit either 1 or 0 in a time interval TB. Okay. Second is M-array scheme. In this case, what we do, in this case, we have got M possible signals, and in these M possible signals, we have to select one of these signals that we will transmit, okay, during the time interval TB. And during this M-array scheme, just only one of the possible message signals is transmitted. Okay, it's all about the classification of the digital modulation techniques.